Okay, so you just kind of worked your way through all or most of the practice quiz, and in this case, I'm going to go through the answers for that, and hopefully it'll help in terms of studying. So, in the case of the first learning target, you were asked to balance these equations as they were given. So, I started by setting up my balancing tree, for lack of a better description of it, and I'm looking at the first equation, and I'm going to go from left to right and identify that in this case I have calcium. I have 1 calcium, 2 aluminums, and 3 sulfates on the reactant side, and on the product side I have 1 calcium, 1 sulfate, and 1 aluminum. In order to balance this, I'm going to start from left to right, and I see that calciums are balanced because there's 1 on both sides. The aluminums are not balanced. There's 2 on the reactant side and 1 on the product side, so I'm going to put a coefficient of 2 here. That will give me my 2 aluminums. And then lastly, my SO4, my sulfate, I see that I have 3 on my reactant side and I have 1 on my product side. So I'm going to put a coefficient of 3 here, which will give me 3 sulfates, but it's going to also give me 3 calciums. So I need to go back and put a 3 in front of that calcium, and then everybody's happy. The next one, I see that I have 7 carbons, 14 hydrogens, and 2 oxygens on the reactant side. On the product side, I have 1 carbon, I have 2 hydrogens, and this little tricky guy right here tells me I have 3 oxygens. Okay, so now I'm going to go ahead and start balancing, and in the process of doing that, I see that I have 7 carbons on the reactant side. I need to have 7 carbons on the product side, so I'm going to put a coefficient of 7 there, which will give me 7 carbons, and then the 7 times 2 for the oxygens gives me 14 oxygens here. So 14 plus the 1 that's there is actually 15 oxygens on the product side. I'm going to start balancing my hydrogens. I have 14 hydrogens on my reactant side. I need 14 hydrogens on my product side. I'm going to put a coefficient of 2 there, which will give me 14. Now that second 7, right, is going to give me now 7 hydrogen or 7 oxygens in the water, plus the 14 hydrogens in the carbon dioxide, the CO2. I believe that adds up to what? 21 oxygens. So to balance this, I'm going to divide 21 by 2 and get 10.5 and throw that 10.5 here and put a 1 there. And everybody's happy, but we can't have 10.5 as you either have all oxygen, like a whole oxygen, or none. You can't have half of an oxygen. So what we're going to do is we are going to multiply all of the coefficients by 2 here. So I have a 2, a 21, a 14, and another 14. And now everybody's happy. So far, so good. And all right. Now I've given you a balanced chemical equation, and we're going to go ahead and draw the model of matter diagrams for said equation. And what I want to point out here is that the equation's already balanced, but there's a 1 here, a 3 here, and a 1 here. And because we can't show state of matter by just drawing one structure, I'm going to double all of the coefficients here to give me 2, 6, and 2. Okay. So when I draw these structures, I have to draw the doubled version so that I can show state of matter. So in the case of the first one, I'm going to draw the Ca3N2, and it's going to look something like this. Square, 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 with some triangle in the middle there. Triangle, triangle. And then I'm going to draw my second one, which will look something like this, with some triangle in the middle there, like that. Like that. And then I have to connect them, right? So I got to have a line here and a line here and a line here and a line here, and then another line here and another line here and another line here, and everybody. So that's my calcium nitride. Solid, touching, ideally, and then organized, right? And then I'm going to draw on the product side, I'm going to draw my calciums, and this time I'm going to draw 6 of them. So 1, 2, 3, 4, 5, 6. So there's my calciums. And then lastly, I'm going to draw my nitrogens. And those nitrogens happen to be a gas. So I'm going to draw my nitrogens, which I said were a triangle. 1, 2. So pairs of 2. And it's going to look something like that. Questions about the first one? The second one we did not have to double because all of the coefficients were a value bigger than 1. And I realized this morning that I forgot to erase this. So you're welcome, because I felt it wasn't fair to give it to the other kids and not give it to you. So if you used it, great. If you didn't use it, no big deal, because I'll show you. So all of these substances happen to be gases, so I'm going to draw them as such. So I'm going to have my triangles, or my carbons and my carbons down here. I'm going to add some triangles like we did for this one in the homework yesterday. Looking something like that. Note that they are definitely not touching, but the things that make up the compound are bonded together like this. But the actual molecules themselves are not touching, so they're just kind of hanging out there in the gas. And then we're going to make 7 oxygens, right? So 7 units of oxygen. So 1, 2, 3, 4, 5, 6, 7, and then we're going to go ahead and connect them like this. And so that's my oxygen. It's gas floating around. Now I have to draw 4 units of carbon dioxide. So I'm going to draw like my 4 carbon squares, sort of like that. And then carbon dioxide, I got to add some O's to it. So I'm going to put an O here and an O here and O here and O here. Actually, it's really a circle. It's not an O. I don't know why I said that. And then I'm going to connect them with lines to show that they're bonded together like that. And then lastly, we've got 6 waters, and we're going to go ahead and add 6 oxygens to start, and then I'm going to go and add some triangles to them. And again, it's a gas, so they're not touching, they're not organized, they're just kind of floating around out there. Oops. Like so. Definitely not my best work in terms of drawing a triangle here. But, you get what you get. You don't get upset. I don't know. Here we go. And everybody's happy. Yay? No? Maybe I'm happy. All right. Now, next one. Here you had to identify the different types of chemical reactions that were given to you in the balanced chemical equation. So the equation was already balanced. And you can go ahead and write the explanation. So I usually can start these by writing the explanation before I even do anything, because I'm just going to look at it and tell me and write what it looks like. So in this instance here, I see that I have, in number 1, I have 1 compound that produces 2 products. And that's it. So like 1 compound produces 2 products. You could have written 1 reactant. You could also have written 1 reactant makes 2 products. Both work. But that's an indication that you have a decomposition reaction. So another thing that you could have remembered was that you had like this AY breaks down to form A plus Y, right? That's another thing that you could have utilized. So there's that. Next one, explanation. Holy buckets. I see that I have 2 reactant let me do this. 2 compounds react to produce or to form 2 new compound products. Okay. And again, so that should tell you that it is a double replacement. And you could also potentially remember that this is like a B X, wow, AY reacts to form BY, and in AX, right? So that's another thing that you could have looked at here. Now, when I post this answer key, what I did is I took all of the notes over the past 3 or 4 days and I put them into one spot, basically. Well, not all of the notes, but a lot of the notes, like the big stuff. Synthesis, here's your generic formula. A plus Y makes AY. How do you write it? 2 elements react to produce one product compound, right? Decomposition, AY breaks down to make A plus Y. One reactant or a compound breaks down to make 2 products. Then we have the single replacement. We got 2 different types, but basically it's the same thing. You have an element reacting with a compound to produce a new compound and an element. Double replacement. You've got 2 compounds react to produce 2 new compounds. See? It's all right there. And then a combustion, a hydrocarbon reacts with oxygen to produce carbon dioxide and water. If I were you and you're struggling with this, I would make flashcards out of this situation. I'd be like, synthesis, and then on the back have some of the stuff. That's what I would do. Or maybe I would draw the generic format and flip it over and have synthesis, and then have 2 elements react. And then I would study, like when I'm standing in line for lunch, or when I'm standing and waiting for the bus, or when I'm standing waiting to use the potty. Have you seen the bathroom sometimes? There's like 800 people there in the bathroom, and half of them aren't using the bathroom. Why? Seriously. Hi. So then we did a lab like a week ago, and I told you a week ago that lab was going to be on the quiz, and here it is. It's right here. So now we're going to go ahead and work through the answers to this part of it. So like in this instance, right, what I'm seeing is that I have the first question, I have some data, and the first question says determine the mass of sodium used during the chemical reaction. So I need this data point and I need this data point to do that. And so when I go and calculate this, I'm going to take the 5.82 grams of sodium minus the 3.53 grams of sodium to produce or equal, where'd my calculator go? So that's going to be the 5.82 minus the 3.53, and that gives me a value of 2.29 grams of sodium. Now, I can't stress enough that you will lose points if you don't have a label and you don't have the unit. If you just put grams, you lose points. If you just put NA, you'll lose points. So make sure you have it all. Show your work, please. Now you're going to go ahead and you're asked to convert mass of sodium to moles of sodium, right? So I'm going to take the 2.29 grams of sodium and convert it to moles of sodium. So we know that 1 mole of sodium is equal to the mass of sodium on the periodic table. I know that the mass of sodium on the periodic table is 22.99 grams sodium. So I'm going to take the 2.29 divided by the 22.99, and I'm going to get something like 0.0996085 something like that. But we need to have 3 sig figs here. So our final answer that we're going to report is 0.996 moles of Na. And again, unit, label. Got to have it. Got to have it for full credit. Pardon? Sure. Okay. Now, the next thing, we're going to talk about tin. I mean, root beer is delicious, man. Haven't had a good root beer in a while. So now we're going to try to figure out how much tin was actually made. So we had this relationship here, this relationship here, and this relationship here. Okay, those are our 2 numbers we're going to use for tin. So let's calculate how much tin was produced. So in this problem, we're going to take the 3.90 grams of tin minus the 0.93 grams of the filter paper, which I'm just going to throw like that. So 3.90 minus 0.93 gives me something like 2.97, again, grams of SN, and yep, label unit. Got to have it, got to have it, got to have it. Now we're going to do moles of tin produced. So we're going to do 2.97 grams of tin, converting it to moles of tin. And according to the periodic table, the molar mass of tin is 1.18.71 grams of tin. And so when I plug this into the calculator, I get something like this. 0.025018935, something like that. But we need to have the right number of sig figs, which in this case happens to be 3. So my final answer that I'm going to report is 0.0250 moles of tin. And again, label unit. Now we're going to slam those two numbers into the decimal ratio situation. So I'm going to take the 0.0996 moles of Na, and I'm going to put it over the 0.0250 moles of tin, and I'm going to divide that situation out. So 0.0996 divided by 0.0250 gives me a value that's like 3.984, which is roughly 4. And the fraction here is 4 over 1. So what that tells me, or what that means to me, is that it's really 4 over 1, which means that the ratio of sodium to tin in this case is 4 moles of sodium for every 1 mole of tin. That's your quiz. That's what your quiz is going to sort of kind of look like tomorrow. If you have questions, please see me or some other chemistry teacher. Otherwise, take this home and review it. Study it, please. You got this. I believe in you. Have a fantastic afternoon.